Hi! Today we're going to be practicing solving two-step equations. So first we start with some bell work, which is a little combination of things we've learned before and things that we're kind of practicing now. So our goal is to get y by itself. So we need to get rid of this 3. It's a positive 3, so we do minus 3 on both sides. And this is kind of weird. Now we have negative y, right, with this right there. It used to be a minus y, but now that there's nothing in front of it, it's now a negative y, equals 12. Well, y is not by itself yet. So, because it still has this negative, so we have to get rid of that. There's an invisible 1 right there. And they're squished together, which means it's multiplied by negative 1. The opposite of multiplying by negative 1 is dividing by negative 1. So now our answer is y equals negative 12. Okay, simplifying exponents. This was from our last unit. When we have division, we need to subtract. Negative 4 minus 3 would give us z to the power of negative 7. But the negative is not what we want, so we need to cross the line and change the sign. So we move that to the bottom of the fraction, so we crossed the line, and now it's a 7, positive 7, so we changed the sign, and that just left a 1 on top. Okay, then this one, draw a picture to represent the situation. The temperature doubled throughout the day, then it went down by 5 degrees, then up by 7 degrees. It's now 25 degrees. There's lots of ways you could have done this, like with, maybe we draw a picture of a thermometer. That looks more like a music note, but that's okay. And then we just say, hey, double, maybe there's our double. And then we show down by 5, and then maybe we show up by 7. And then maybe we show that this is now 25 degrees, something like that. That's not what your picture had to look like, but that's just an example of what you could have had. Our goal today is to solve two-step equations. We're practicing this. You're not going to need your notebook. First, we start with some practice problems to try on your own, but we'll just go through them together. Our goal for this first one is to get a by itself. So we have to get rid of the 4 and the 2. And it does matter which order we do those in. So remember, the 4 and the a are squished together. They're buddies, they're best friends. So we leave the 4 alone for a minute. And first we get rid of the 2, because it's kind of off by itself. It's not really hanging out. So what's the opposite of a plus 2? Minus 2 on both sides of the equal sign. 2 minus 2 is 0. So now all we have is 4a equals 18 minus 2 is 16. Okay, well that 4 and that a, now it's time to split them up. What operation splits things up? Divide. So we're going to divide by 4 on both sides of the equal sign, and a equals 4. All right, over here our goal is to get b by itself. This negative 12 and the b, they're the buddies, they're best friends, they're sticking close together. And then there's this 3 over here just kind of hanging out by itself. So that's what we're going to get rid of first. The opposite of a minus 3 is a plus 3 on both sides of the equal sign. Negative 15 plus 3 is negative 12 equals negative 12b. And this one's a little tricky. Some people might think, oh, there's a negative, so I should do plus 12. No, that's a negative 12 squished right next to a b. There's an invisible operation right there in the middle, and that's multiply. So we have to do the opposite of multiply, which is divide by negative 12 on both sides of the equal sign. Anything divided by itself just equals 1. So negative 12 divided by negative 12 is 1. A couple more practice problems. Our goal is to get c by itself. Now, it looks a little different, but still, c and 3 are the ones that are connected to each other. They're the best friends. So we leave that alone for a minute. And now we look at how to get rid of this minus 4. The opposite of a minus 4 is a plus 4 on both sides of the equal sign. So now we just have c over 3 equals 5 plus 4 is 9. Now it's time to get rid of the best friend. We have divided by 3. The opposite of dividing by 3 is multiplying by 3 on both sides of the equal sign. 3 divided by 3 is 1. C times 1 is just c. And then 9 times 3 is 27. Okay, over here we have something kind of similar. The d and the 7 are together, but this 4 we have to get rid of is a positive 4. So we do, what's the opposite of a positive 4? It's minus 4. And that feels weird because of this symbol, but we'll get to that in a minute. Minus 4 on both sides of the equal sign. 10 minus 4 is 6. 4 minus 4 is 0, so we just get rid of that. Now we have this negative d over 7. Okay, the negative sign's right in front, but we can attach it to the 7 and say, okay, what's the opposite of dividing by a negative 7? Multiplying by a negative 7. Okay, negative 7 divided by negative 7 is 1. 1 times d is just d. A negative times a positive is a negative, and 7 times 6 is 42. So d equals negative 42. Okay, we got some extend your thinking. That means these are not going to be straightforward, follow a procedure and solve kinds of things. These we're going to have to do a little bit more thinking with. Using the numbers 1 through 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill in the blanks of this equation so that when the equation is solved, the answer is x equals 1. There are multiple correct ways to fill in the equation. Okay, what I would think of to do is just put in something random to start with. Let's just put in like a 1 and a 2. Okay, and just see what happens. Okay, if I subtract 5 on both sides, that gives me 1x, which is just x, equals negative 3. Okay, well that's not going to work for me, is it? So let's go ahead, erase it, maybe. Yeah, good. Let's go ahead and erase it, and now we can start to be strategic. Like, okay, well I'm going to be multiplying x times something, and eventually we know this is going to be a 1, and then adding 5 to get something else between 1 and 9. So if I multiply it times 2, right here, if I multiply 2, and then 2 times 1, because I know this has to be a 1, 2 times 1, plus 5, well 2 times 1 is 2, plus 5 should equal 7. So it should work for me to do a 2 right here and a 7 right here. Let's find out. Subtract 5 on both sides, and now I get 2x equals 2, divide both sides by 2, and x equals 1, just like we wanted. That is not the only solution. That was just because I put a 2 here, and then I knew, multiplied it times 1, I added 5, and I just solved what it would be. Using the numbers 1 through 9, fill in the blanks of this equation so that when the equation is solved, the answer is x equals 2. There are multiple correct ways to fill in the equation. So same as before, maybe I could just put in something random, but I noticed that I'm going to be dividing by 4. So I would love to put a number here that is divisible by 4. Okay? So 4 divided by 4 is 1, and I know this is also going to end up being a 1. So 1 times 1 is 1, plus, it has to be plus 9 to get 10. This is not the only option we could have chosen, but this is one correct answer. Okay, now we have some more practice. Our goal is to get a by itself, so we get rid of the 2 first because the 3 and the a are together. Negative 13 minus 2 is negative 15. 2 minus 2 is 0. Some people like to write the 0. I don't, I just cross it off. And then we have a positive 3 times a. Well, what's the opposite of multiplying by 3? Dividing by 3. Negative 15 divided by 3 is negative 5. 3 divided by 3 is 1. 1 times a is just a, so negative 5 equals a. We have a bunch of these just big practice questions. Feel free to pause, feel free to rewind as needed to help you learn. Our goal is to get b by itself, so first we have to get rid of the number not squished with it, not the best friend. So in this case, further away is that 4. It's a positive 4. So the opposite of a positive 4 is a minus 4 on both sides of this equal sign. 4 minus 4 is 0. So now we have a negative 5b, because of this symbol, negative 5b equals 15. Divide both sides by negative 5, because this does not say b minus 5. This says negative 5, and then there's this invisible multiplication symbol right there, times b, and the opposite of multiplying is dividing. And if I divide by by negative 5 on this side, I have to divide by negative 5 on this side. Negative 5 divided by negative 5 is 1. 1 times b equals b. 15 divided by negative 5 is negative 3. All right, subtract 1 on both sides. C over 6 equals negative 9. The opposite of divide is multiply. And then C equals, what is that? 6 is 54. Negative 54. Write your answer as a decimal rounded to the nearest hundredth, so that's a hint that we might get a crazy decimal, and as a simplified fraction. I wonder what that would look like. The rules are still the same even though we have decimals. There's this invisible multiplication sign here, combining the 2.1 and the d. So we get rid of the 3.7, it's a positive 3.7. The opposite of a positive 3.7 is a negative 3.7. Subtract 3.7 on both sides, and then we get 0.5 minus 3.7 is negative 3.2. That's an announcement, that's okay.
Please come to the office, London Edwards.
Now we have 2.1 squished together with the d, so that's multiplication. The opposite of multiply is divide by 2.1 on both sides. And divide by 2.1 gives me a long decimal rounded to the nearest hundredth. It's negative 1.52. Or as a fraction, it's negative 1 and 11/21. Okay, then you had time to work on your homework, and here's our exit ticket. Okay, these are probably going to look a little bit familiar. This one looks very familiar. Subtract 3 on both sides, and we get negative y equals 12. There's that invisible 1 in front. Divide by negative 1 on both sides, and y equals negative 12. Okay, this one has decimals. That doesn't change how you do it. Subtract by 5 first, then divide by negative 3.2. The last one, fill in the blanks with the numbers 1 through 9 so that when the equation is solved, the answer is x equals 3. There are multiple correct ways to fill in the blanks. So what if I just put a 1 right here? Well, I happen to know that this is going to be a 3. So it's 3 times 3, that's 9. That's going to be 9. Plus 1, that's going to equal 10. Well, that's not the numbers 1 through 9, but that still worked. I'm fine with that. Okay, that was solving two-step equations. You got this.